paper of the day is ARIES, a transaction recovery method supporting fine granularity, locking, and partial rollbacks using write-ahead logging. ARIES stands for Algorithm for Recovery and Isolation Exploiting Semantics. In this paper, we present a simple and efficient method called ARIES. It stands for Algorithm for Recovery and Isolation Exploiting Semantics, which supports partial rollbacks of transactions, fine granularity, that is record, locking, and recovery using write-ahead logging. We introduce the paradigm of repeating history to redo all missing updates before performing the rollbacks of the loser transactions during restart after a system failure. ARIES uses a log sequence number in each page to correlate the stage of a page with respect to logged updates of that page. All updates of a transaction are logged, including those performed during rollbacks. By appropriate chaining of log records written during rollbacks to those written during forward progress, a bounded amount of logging is ensured during rollbacks, even in the face of repeated failures during restart or of nested rollbacks. We deal with a variety of features that are very important in building and operating an industrial strength transaction systems. ARIES supports fuzzy checkpoints, selective and deferred restart, fuzzy image copies, media recovery, and high concurrency lock modes, example increment and decrement, which exploit the semantics of the operation and require the ability to perform operation logging. ARIES is flexible with respect to the kinds of buffer management policies that can be implemented. It supports object of varying length efficiently. By enabling parallelism during restart, page-oriented redo, and logical undo, it enhances concurrency and performance. We show why some of the system are paradigms for logging and recovery, which are based on shadow page technique, need to be changed in the context of val. Motivations. For a database to be useful in industrial settings, it needs to provide strong guarantees that data cannot be lost. This implies that the database must be able to recover from error conditions. The paper describes an algorithm for recovery from three different kinds of failures: transaction failures, DBMS crashes, and storage media failure. Here is the high-level proposed solution. The fundamental idea of database recovery is to log logical changes to the database to durable storage before applying those changes to the actual database. If this protocol is followed, then any failure can be recovered by using the changelog itself. The simple idea is used throughout the paper to illustrate the recovery algorithms for transaction failure, crashes, and storage media failure. As part of ARIES protocol, each log is assigned a log sequence number, which uniquely identifies the log record. Further, each page in the database records the LSN that modified the page. ARIES also tracks any in-flight transactions to be able to fully restore the database to the point in time of the crash before doing full recovery. To perform recovery, ARIES uses the log and the transaction table during three passes. First is the analysis pass, then redo, and then undo. During the analysis pass, the log is scanned to extract the dirty pages and in-flight transactions from the point of failure, determining the starting point where the redo is required and the in-flight transaction that must be rolled back. During the redo pass, the database is stored to the state it was at the time of failure. Finally, during the undo pass, any in-flight transactions that have failed have their changes rolled back. Combining these three passes restores the database to a consistent state. Here are some of the key ARIES attributes which are listed in the paper. First is the support for finer than page concurrency control and multiple granularities of locking. ARIES supports page level and record level locking in a uniform fashion. Recovery is not affected by what the granularity of locking is. Depending on the expected contention of the data, the appropriate level of logging can be chosen. It also allows multiple granularities of logging, example record, table, and table space level. For the same object, concurrency control schemes other than locking can also be used. Second, flexible buffer management during restart and normal processing. As long as the write-ahead logging protocol is followed, the buffer manager is free to use any page replacement policy. In particular, dirty pages of incomplete transactions can be written to non-volatile storage before those transactions commit. That is the steal policy. Also, it is not required that all pages dirtied by a transaction be written back to non-volatile storage before the transaction is allowed to commit. That is no force policy. These properties lead to a reduced demand for buffer storage and fewer IOs involving frequently updated pages. ARIES does not preclude the possibilities of using deferred updating and force-set commit policies and benefit from them. ARIES is quite flexible in these aspects. Third, minimal space overhead, only one LSN per page. The permanent space overhead of this scheme is limited to the storage required on each page to store the LSN of the last logged action performed on the page. The LSN of a page is a monotonically increasing value. No constraints on data to guarantee idempotence of redo or undo logged actions. There are no restrictions on the data with respect to unique keys, etc. Records can be of variable length. Data can be moved around within a page for garbage collection. Idempotence of operation is ensured since the LSN on each page is used to determine whether an operation should be redone or not. Fifth, actions taken during the undo of an update need not necessarily be the exact inverse of the actions taken during the original update. Since CLRs are being written during undos, any difference between the inverse of the original action and what actually had to be done during the undo can be recorded in the former. Sixth, support for operation logging and novel log modes. The changes made to a page can be logged in a logical fashion. The undo information and the redo information for the entire object need not be logged. It suffices if the change field alone are logged. Since history is repeated for increment and decrement kind of operations, before and after images of the field are not needed. Information about the type of operation and the decrement or increment amount is enough. Garbage collection actions and changes to some fields of that page need not be logged. Novel log modes based on the commutative and other properties of operations can be set. Even redo and undo records are accommodated. While it may be efficient and or necessary to log the information in two different records, ARIES can handle both situations. Under these conditions, the undo record must be logged before the redo record. Support for partial and total transaction rollback. Besides allowing transactions to be rolled back totally, ARIES allows the establishment of save points and partial rollback of transactions to such save points. Support for objects spanning multiple pages. Object can span multiple pages, which consist of multiple segments may be scattered over many pages. When an object is modified, if log records are written for every page affected by that update, ARIES works fine. ARIES itself does not treat multi-page objects in any special way. Allows files to be acquired or returned anytime from to the operating system. ARIES provide the flexibility of being able to return files dynamically and permanently to the operating system. Such an action is considered to be one that cannot be undone. It does not prevent the same file from being relocated to the database system. Mappings and files are not required to be defined statically as in system are. Some actions of a transaction may be committed even if the transaction as a whole is rolled back. This refers to the technique of using the concept of dummy CLR to implement nested top actions. File extensions has been given as an example situation which could benefit from this. Efficient checkpoints. By supporting fuzzy checkpointing, ARIES makes taking a checkpoint an efficient operation. Checkpoints can be taken even when update activities and logging are going on concurrently. Permitting checkpoints even during restart processing will help reduce the impact of failures during restart recovery. The dirty pages information written during checkpointing helps reduce the number of pages which are read from non-volatile storage during T2 pass. Simultaneous processing of multiple transactions in forward processing and rollback accessing same page. Since many transactions could simultaneously be going forward or rolling back on a given page, the level of concurrent access supported could be quite high. No locking or deadlocks during transaction rollback. Since no locking is required during transaction rollback, no deadlocks will involve transactions that are rolling back. Avoiding locking during rollback simplifies not only the rollback logic but also the deadlock detector logic. Bounded logging during restart in spite of repeated failures or nested rollbacks. Even if repeated failures occur during restart, the number of CLRs written is unaffected. This is true if partial rollbacks are nested. The number of log records written will be the same as that written at the time of transaction rollback during normal processing. Permit exploitation of parallelism and selective deferred processing for faster restart. And 17th, fuzzy image copying for media recovery. Media recovery and image copying of the data are supported very efficiently. Continuation of lose a transaction after a system restart. Since ARIES repeats history and support the save point checkpoint, We could, in the undo pass, instead of totally rolling back the loser transaction, roll back each loser only to its latest save point. Only one backward traversal of log during restart or media recovery. Both during media recovery and restart recovery, one backward traversal of the log is sufficient. This is especially important if any portion of the log is likely to be stored in a slow medium like tape. Need only D2 information in the compensation log records. Support for distributed transactions. ARIES accommodate distributed transactions. Whether a given site is a coordinator or a subordinate site does not affect ARIES. Early release of logs during transaction rollback and deadlock resolution during partial rollbacks. Because ARIES never undoes CLRs and because it never undoes a particular non-CLR more than once during a rollback, when the transaction's very first update to a particular object is undone, a CLR is written for it. The system can release the log on that object. This makes it possible to consider resolving deadlocks using partial rollbacks. It should be noted that ARIES does not prevent the shadow page technique from being used for selected portions of the data to avoid logging of only undo information or both undo and redo information. So overall, here's the key contributions of this paper. ARIES presents and validates the concept of write-ahead logging, providing industrial strength support for atomicity and durability. As described in the Red Book, write-ahead logging is a near ubiquitous technique for maintaining durability. ARIES provides the reference implementation for no-force steel write-ahead logging used by most database systems today. With a no-force policy, transactions can be committed without actually flushing the dirty pages to disk, while a steel policy implies dirty pages can be flushed to disk at any time. Combined, these two policies allow for high performance as the current state of pages in the database can be kept in memory, avoiding unnecessary I/O operations.